Hello everyone, welcome to my mornings. I'm Falguni, your chemistry SME. I hope your preparations are going in full swing. So let's start with today's DPD. So our first question is, if 1 gram of sodium hydroxide is treated with 25 ml of zero point 0.5 molar HCl, the mass of NaOH left unreacted is. So see, what we will use, the chemical reaction. Just a second. Hmm. See, HCl plus NaOH to give NaCl plus H2O. Okay, so we'll firstly find the weight of HCl that is required by using the formula of molarity, which is number of moles of solute upon volume of solution. Okay, so we all know this is weight upon molar mass, moles. So this is the formula we'll get, and we'll substitute it in this formula. All the values that are given to us of the molarity, molar mass of HCl, 35.5 for chlorine plus 1 for hydrogen. Okay, volume 25 is given, and this is what we'll guess. See, 0.456 gram of HCl is reacted. Okay, now if you see the stoichiometry, 1 is to 1 is the stoichiometry of HCl and NaOH. Okay, so what is the molar mass of NaOH? That is 40. Okay, so 36.5 gram of HCl reacts with 40 gram of NaOH. So using the unitary method, 0.456 gram will react with 40 upon 36.5 into 4.56. See, if 36.5 reacts with 40, then 1 reacts with 40 upon 36.5, and then 0.456 will react with how much? 40 by 36.5 into 0.456. Okay. So what we'll get 0.449 which reacts, and what is asked unreacted. So total 1 is given, so we'll subtract it. Okay. So that is why we are subtracting. This is in mg. Okay. In gram we will get 0.501 grams, and upon converting to mg we'll multiply by 1000. This is what we will get. So this would be the correct answer. Let's move to the next question. What is the normality of 1 molar solution H3PO4? What is normality? Normality will be equals to N into molarity. What is N? Let's see. Okay, see here. How many number of H plus ions are produced on dissociation? Okay, here 3 H plus ions will be produced because H3PO4 is there. So it is 3. So 3, just a second. So it would be 3 into 1, that is already given, so it would be 3 normal. This is the correct answer. Let's move to the next question. It is given that what is the energy of 1 mole of photons of radiation whose wavelength is 440 nanometers? See what formula we will use. Normally the energy is equals to h nu, that is equals to h c by lambda. Okay. And if we need to find for 1 mole, then we'll multiply by Avogadro's number. Okay. So we know the value of Planck's constant, that is 6.6 into 10 to the power minus 34 joules second. And we know the speed, that is 3 into 10 raised to the power 8. Okay. So lambda is already given. This is in nanometers. Therefore, we'll convert it into meters. We need to put SI units. So it would be 10 to the power 9 minus 9 meters. Okay. And then this is Avogadro's number. And upon calculation, we'll get this answer. So this would be the correct answer. Let's see the next question. It is given that which of the following statements is not true about hydrogen bonding? Okay. See, here it arises due to strong dipole-dipole interaction, attraction between the molecules. It is responsible for high boiling point of water. It involves a hydrogen atom bonded to a highly electronegative atom. It is a weak interaction compared to ionic or covalent bonds. Let's see what is hydrogen bonding. In this, there is hydrogen. It is interacting with an electronegative that can be oxygen or nitrogen or chlorine. Okay. So what happens is it is a stronger interaction than obviously London forces or van der forces, but weaker than covalent or ionic bond. So which would be our incorrect statement? This is our incorrect statement. See, it is obviously responsible for high boiling point of water because if strong interactions are a bit stronger, the boiling point would be more. Okay, so it is a weak interaction compared to ionic and covalent bonds, but stronger than London dispersion forces. Okay, so this is our answer. Let's see some more reasoning. Covalent bonds are stronger than hydrogen bonds. Why? Because in hydrogen bond there is no sharing of electrons. Okay, but in covalent bond there is a sharing of electrons. So it makes it more difficult to break. Well, now let's move on to the next question. That is 55 question. It is given to us that, just a second, I'll read. It is given to us that for a given Nernst equation, this is the given Nernst equation, which of the following representations is correct? See, for a cell representation, this is a salt bridge. Here we have a node representation in the left and cathode in the right. Okay. At anode, what happens? Oxidation. Whereas at cathode, reduction takes place. Okay. So see, you have to see where oxidation or reduction is taking place. In this, we know in the numerator we put product. That is, if we are getting Mg2 plus, that means the reaction would obviously be this. Okay, oxidation reaction. So it would come on left hand side. Okay, and it would be Mg2 Mg2 plus. Oxidation is there. Okay, then a salt bridge. And then see, this is reduction. So the reaction would be this. That is from Ag, we are getting from Ag plus, we are getting Ag. Just a second. Yep. So from Ag plus, we are getting Ag. From plus 1 to we are going to 0. Okay. So what is the answer? This is the answer. Let's move to the next question. In this, we have to match the following. Okay. So this is very easy. Molarity, we all know what is molarity. It is the moles of solid that are dissolved in 1 liter of solvent. Therefore, it would be mole per liter. Okay, so this moles per liter. Okay, and then mole fraction, since it is a fraction, so it would be unitless. Okay, it is the ratio of moles of component upon total moles. Okay, so it would not be any unit. Mole, simply it's mole. Molality, that is the amount of solid dissolved in 1 kg of a solvent. So it would be mole per kg. Density, we all know mass upon volume, that is gram per liter. So what is the correct answer? It is this. So let's move to the next question. That is question number 57. The plot of osmotic pressure versus concentration for a solution yields a linear relationship with a slope of this. And what is the temperature of osmotic pressure measurement at which the osmotic pressure measurement was conducted? Okay, see what we will do here is it is given that it follows a linear relationship. That is, a straight line equation is there. Okay, and the slope value will be what? See here. We all know for osmotic pressure, we use CRT. That is Y equals to XM. Okay. So what is the slope? If it is given that concentration and osmotic pressure. So concentration would be X on x-axis and osmotic pressure would be on y-axis. So M would be RT. Okay, R value is given to us 0.09 liter bar per mole per Kelvin. Okay, so we'll just put the values. Slope is already given 30.50 and we'll get the answer to be this. Okay, this is in Kelvin. These are given in Celsius. So we'll subtract 273. Our answer would be 94 degrees Celsius. Now let's move to the next question. See, volume of CO2 obtained at STP by burning 32 gram CH4 with 64 gram of oxygen. See, either we only need any one. See this combustion equation for methane. So, how much is the given mass? 32 gram of CH4. We'll divide by 16, that is the molar mass, but we'll get 2 moles of CH4. Now C. At STP, we know that 1 mole requires 22.4 liters. Okay, and then how much you see? It is given that 2 moles are there. We found that out. Okay, 2 moles are there. So 2 moles of CH4 will give 1 mole of CO2. So how much will be given by 1 mole of CH4? That is 1 by 2 mole of CO2. I told you earlier, this is unitary method. Okay. So 1 mole of CO2 would contain 22.4 by 2 liters. That is 11.2. So this would be our correct answer. We used 2 moles because it was given that 32 grams is used. Okay. Let's move to the next question. That is, sodium chloride is an ionic compound. Which of the following statements accurately describes the bonding? See the word accurately. There may be statements that are correct, but we have to tell the most accurate statement. Sodium metal donates an electron to chlorine gas to form a stable octet configuration. Second, sodium and chlorine share electrons to form a covalent bond. Electrostatic attraction between Na positive and Cl negative holds the crystal structure. Both sodium and chlorine lose their identities and form a new molecule. So what happens in NaCl? Na and Cl, these are both ions and ionic bond is formed. Okay. So the most accurate answer is this. Ions have electrostatic interaction. Okay. So this is the principal interaction in ionic compounds and it has electrostatic interaction that I told you. Okay, between two oppositely charged ions. See, what happens in this is that neutral sodium atom, how will it achieve its complete octet configuration? While it is Na, we have, okay, one extra electron, so it will go to get a stable configuration. It will form Na positive. Okay. In chlorine, it has 7 electrons, so it will gain 1 electron. Okay, so for octet we need 8 electrons, so it will easily gain 1 electron. It is not easy to lose 7 electrons rather than gaining an electron. So this will make sodium slightly positive and chlorine slightly negative. So see, sodium will become Na positive as I told, and chlorine becomes Cl negative. So this is the bonding transfer electron will take place, which will result in the formation of ions. So now let's move to the next question. The next question is, which of the following statements regarding the cell representation is are correct? I explained you how cell representation is done. Now you should be able to answer this. In the given cell, cadmium electrode acts as anode, whereas Ag acts as a cathode. At anode, oxidation occurs. Oxidation is occurring at anode. At cathode, reduction will occur. It is reducing. So it is the correct statement. In the given cell, CD acts as cathode. This is false. If this is true, then this will obviously be false. And how we find the cell potential? By E cathode minus E anode. Okay. E cell is equals to E cathode minus E anode. Okay. So this is the correct representation. So what is the answer? That is first and third. Okay, I told you earlier in galvanic cell, anode is where oxidation occurs and its cathode reduction takes place. And anode is on left and cathode is on right. So you get it. So the next question is the total number of electrons present in 27 gram of Al3 positive ions. C. Al3 positive, aluminium is 13. 3 positive would give 10 electrons. Okay. So let's find the moles. Given mass is 27 and molar mass is 27. That is 1 mole. Okay. So if one aluminium ion has 10 electrons, 1 mole of aluminium ion will have 1 into what? Avogadro's number. Okay, 1 mole is there. So we'll multiply by Avogadro's number whenever we have mole. So 10 electrons of Al3 positive, then it would have 10 into Na. Okay. So this is a bit conceptual, but it is important. Let's see the next question. If the molarity of the dilute solution is doubled, what will happen to the value of molar depression constant? See, the value of molar depression constant will not depend upon the nature of the solute. Okay, it is written. It will only depend on the nature of solvent. So, dilute solution implies a small amount of solute won't essentially change the volume in the final product. See, solute is very small in quantity, whereas in final volume, as compared to final volume, it is smaller in quantity. So dilution on decreasing the concentration, not much effect would be there on Kf. So it will be unchanged if the molality of the dilute solution is doubled. It only depends upon the nature of the solvent. The next question is match the oxides. Okay, let's see. So see, um, N2O. This is neutral. The neutral oxides. Wait, this is neutral because neutral oxides are neither acidic nor basic. Okay, and amphoteric oxides they react with both acids and alkalis. Okay, so to form salt. So Al2O3 is an amphoteric oxide. See now Cl2O7. On hydrolysis, it will form acidic solution. So it is an acidic oxide and Na2O is basic oxide. Okay, so metal oxides, NaC is the metal, sodium. Basic oxides, metal oxides form basic in nature, while non-metallic oxides are acidic in nature. Okay, so our correct answer would be first. Let's see the next question. Which of the following molecule exhibits a triple bond between two carbon-carbon atoms? See, when there is no unsaturation. Okay. For example, in alkanes, they have single bond, whereas alkenes they have double bond, and alkynes they have a triple bond. So, which is an alkyne? Only ethyne. So it has a triple bond. So this is the correct answer. Let's move to the next question. For the cell representation, which of the following is correct? See, now I already explained you the cell representation. Which of the following is correct? Cu is reducing agent. C. It oxidation takes place. It is at left. Oxidation occurs. That is, it will reduce others and act as a reducing agent. So this is the correct statement. The overall statement, the overall cell reaction is given to be this. C. This is not correct. Why? At anode, what happens? Oxidation is there. Okay. At cathode, reduction is there. So this is the net reaction. See, wait, this is right. Okay, this is right. This is the overall reaction because oxidation is taking place here and reduction is taking place here. Okay, so this is the overall reaction. So this is also correct. Cu is cathode. This is false. Ag is anode. This is also false. Opposite is true. So fourth would be the correct answer. Okay. Let's see the next question. A sample was weighed using two different balances. The results were from first balance we got 3.929 grams, plus from second balance we got 4 grams. So what is asked? How would the weight of the sample be reported? Okay, see, when we have to tackle such questions, we see accuracy and precision. Okay. So out of these 3.929 is more accurate because it is more closer. Like in decimal, we are getting the answer. So it will be reported, but how? After rounding off. Okay. So this is the approach. That there's a very marginal difference between two values. We can round off. Like from 3.929 to 4. Rounding off can be done. It's not like 3.99 or 4. That upon rounding off we'll get 4. Okay. So the value 3.929 tells the precision of the weight, while 4 indicates the accuracy. So we can round off to make it accurate and precise. And how to round off? See in point 3.929, this last value is greater than 5, so we'll add up to this here and it will become 0. It would be 3.93. So this would be reported. Let's see the next question. That is match the following. Okay, see what is mass percent? Mass percent is mass of solute divided by mass of solution into 100 and it is used in industrial chemistry. Why? To specify the concentration of a solution. So it would be used in industrial chemical applications. And what is mass by volume? It is mass of solute upon volume of solution into 1000. It is used in medicines and pharmacy. You will see the units in this formula behind any medicine or syrup bottles. So it is used like this. ppm. See where it is used. It is used to tell the concentration of pollutants in water. Like, or this is like we have any concentration of a dye, for example, that is this much ppm. We try to degrade it. We try that. Okay. So that is the concentration. And parts per million is frequently used to express very dilute concentration of substances such as pollutants in water. That I already told you. Volume percentage, that is the volume of solute upon volume of solution. And it is often used to describe the concentration of liquid solutes in liquid solutions. Okay. So what is the correct answer? It is option number 4. Let's see the next question. In next question, chlorine has two isotopes, 35Cl and 37Cl. If the percentage abundance of lighter isotope is 75%, then what is the average atomic mass of atom? See, chlorine has two isotopes. Each has atomic mass as 35U and 37U. Okay, and it is given that the percent of lighter isotope is 75%. That is, it is 3:1. Okay, how? 75 by 100 minus 75, that is 25. This is 3:1. So, and how we find the average atomic mass? This is by the mass of isotope into its relative abundance. Note this. This is important. So, this is how we find it. So, what we'll do is, see, 75% to 25%, which can be written as 75 upon 100 by 20, to 25 by 100. That is 3 by 4 is to 1 by 4. That is the relative abundance. Okay. We'll multiply these by their atomic masses and add them. So what we will get is 35.5. That is why you see in the first question we use 35.5 for Cl. Now let's see the next question. The Lewis structure of ammonia shows three single bonds between nitrogen and hydrogen atoms with a lone pair on the central nitrogen atom. What is the electron domain geometry around the nitrogen atom? See, in nitrogen, the structure geometry is like this. Okay? This is the lone pair. So it is tetrahedral. See, ammonia and shape would be trigonal pyramidal. This would be the shape. In shape, lone pairs are not counted. So ammonia is a due to the presence of three bonding electrons and one lone pair. I told you this. The nitrogen atom has five valence electrons. In NH3, three of the five are involved in bonding with hydrogen, as I told you. See, this is hydrogen, this is of nitrogen. And the other two are left as 3 minus 5, that is 2 are left as lone pair. So it exhibits trigonal pyramidal shape. Okay? And geometry is tetrahedral. Note the difference between geometry and shape, which is very important. Now, let's see the next question. It is given that reaction takes place at anode in a dry cell. See what happens in a dry cell. Oxidation occurs at zinc anode to form zinc cations. So zinc will lose two electrons and form Zn2 plus. Okay, so oxidation half reaction would be this. At anode, oxidation takes place. Now let's see the next question. The average atomic mass of neon. We saw this earlier now. Relative abundance into what would be the mass that we will be using. So see, average atomic mass 20. The mass number that is given 20 into that is the relative abundance. This 21 and the second one, and then 22 and the third one. And upon adding all these, we'll get this much. That is the correct answer. Now let's see the next question. 4 mole of a mixture of Mohs salt requires 500 ml of 1 molar K2Cr2. Okay. For complete oxidation in acidic medium, the mole percent of Mohs salt in the mixture is. We have been asked the mole percent. What is the chemical reaction? Cr2O7 2 minus plus 6 Fe2 plus 14H plus to give, see, it's already written here. 2 Cr3 plus 6 Fe3. You know how to balance the equation, right? Now see, uh, in this, what is the change of electron in from Fe plus 2 to Fe plus 3? It is 1, so N would be 1. Okay. And for Cr2O7, it would be 6. Okay. So let's see now what happens is we know that equivalent of Mohr salt reacting will be equal to the equivalence of potassium chromate. That is, this can be done that moles of Mohr salt into NF, N factor, will be equals to the moles of potassium dichromate into N factor because same equivalents are always there. Every equivalent would be same. So N into 1 and 1 into 500 into 10 to the power minus 3 into 6. Okay, that will give us N equals to 3. So see, now total moles are 4 because 4 mole of a mixture is reacting, and if N equals to 3, then total would be 3 plus 1 equals to 4. So 3 by 4 would be the moles. Okay, so that is why we'll multiply 3 by 4 into 100 to get the mole percent. Moles of Mohs salt upon total moles into 100. So we will get 75. Let's see the next question. A metal sheet has a work function of 5 electron volt. The kinetic energy of photoelectron when the metal sheet is irradiated by an electromagnetic wave of frequency 2 into 10 to the power 15 hertz is C. What formula we will use? Maximum kinetic energy is equals to h nu minus h nu naught. Okay. So we have to find the maximum kinetic energy. H nu is already given 2 into 10 to the power 15 hertz. And h nu naught is also given, that is 5 electron volt. We'll convert it into joules. How? By multiplying by 1.6 into 10 to the power minus 19. So Planck's constant value into what is nu minus h nu naught. So this will give us this much answer. That is 5.2 into 10 to the power minus 19 joules. Let's see the next question. Carbon dioxide exists as a linear molecule. What type of hybridization does the central atom undergo in CO2? What is the structure of CO2? See, this is the structure of CO2 which is linear. That is why it would be sp. Okay. In this case, we have sp2. And if this is the case, we have sp3. So let's move to the next question. Consider the following statements. The conductivity of an electrolytic solution increases on dilution. No, this is false. We'll see why. The molar conductivity of an electrolytic solution increases on dilution. Yes, this is true. So this is the correct answer. Because here the lambda m is inversely proportional to concentration. Okay, so as dilution occurs, that is concentration decreases, lambda m will increase. Okay, so let's see on dilution, number of ions per ml decreases. So if I have 1 molar solution, okay, and if I dilute it to say lesser concentration, so what happens is number of moles per ml will decrease. What is molarity? Mole per liter. So it would decrease. If this was 1 and now after dilution, say it is 0.5. So lesser number of ions are there. So number of ions are less, then lesser would be the conductivity. Okay. So that is why statement 1 is false. And I told you it's inversely proportional. So lambda m is inversely proportional and hence it will increase upon dilution. Dilution means decrease of concentration. Okay. Now let's see the next question. Amount of 32.2 gram Na2SO4 or 10H2O. Amount of oxygen in 32.2 gram of this much. So, okay, let's see. We'll find the molecular weight of Na2SO4 or 10H2O, which will come out to be 322 grams. Okay. And it has, see how many? 14, 10O plus 4O. That is 14O. See here 10, here 4. Okay. So 14. Okay. So see now. 322 gram of Na2SO4 is 224 gram. 14 into 16. 224 gram of oxygen. Then 1 gram will have 224 by 322. Okay. So how much will 32.2 gram will have? Into 32.2. So this is a normal unitary method. So this would be the answer. 22.4 gram. Okay, let's move on to the next question. Select the incorrect statement. Dissolution and crystallization are opposite process. Yes, this is true. In dissolution, we dissolve any ion, we break it. Okay, in crystallization, we form a solid. That is, ions come together. When dissolution and crystallization occur at the same rate, a saturated solution is obtained. Yes, For example, see, whenever you will like dissolve salt in water, for example, so it will dissolve till a limit. But when you start dissolving more, then you will see some salt settles down. That is, it precipitates. After saturation, you cannot dissolve more salt. So this is also the correct statement. When rate of, let's see the third statement, rate of dissolution equals to rate of crystallization in a saturated solution, more solute can be added to it. This is the incorrect statement. I told you, I gave you an example. See, NaCl, when added more than saturation, it settles down. That is precipitate forms. You cannot add more solute. Okay, so that is why this is the correct statement. Incorrect statement. In fourth, in saturated solution is in dynamic equilibrium with the dissolved solute. Yes, it is in equilibrium. That is why this is a saturated solution. Okay, so let's see the next question. We have to again match. Let's see first of all what are alpha particles, beta and gamma. Okay, alpha particles positively charged particles that consist of two protons and two neutrons and have charge of +4, helium-4 nucleus. No, which is equivalent to helium-4 nucleus charges of +2. And they are usually emitted from the nuclei of heavier radioactive elements. Now, beta particles, they are fast moving beta electrons, beta negative or positrons, beta positive. Okay, so they are negatively charged and are similar to electrons. Let's see for gamma. Gamma rays, these are similar to X-rays but have higher energy. So they are neutral like X-rays because X-rays are also neutral. So let's see now what are the options. Alpha rays, we know now this is 2 units of positive charge and 4 units of atomic mass. Beta rays, these are negatively charged, and gamma rays. So, which is the correct answer? A3, B1, and C2. Let's see the next question. Which of the following molecule exhibits metallic bonding? See, metallic bonding is exhibited only by metals. Out of these, which is a metal? This is a metal. This is the correct answer. See, metallic bonding involves a sea of delocalized electrons shared by metal cations in a lattice structure. So it is a metal, iron, so it will exhibit metallic bonding. Okay, let's see the next question. A depolarizer used in dry cell batteries is. For this, MnO2 is the correct answer. Why? Let's see. What is a depolarizer? These are the substances that are employed in primary cells. Why? Because we have to stop hydrogen gas bubbles from accumulating. Okay, we have to stop this. So it will act as an oxidizer because it will absorb electrons. Okay, what will oxidizer do? It will absorb electron during the cell discharge. See, the moistened electrolyte undergoes a reduction reaction that involves the elements MnO2 and NH4Cl. So you see, MnO2 would be the correct answer. How many sucrose atoms are contained in 1 mole of sucrose? This is the formula for sucrose. 1 mole will contain Na atoms, okay? That is 6.2 into 10 to the power 23. Now you will have to add how many atoms are there in this. 12 plus 22 plus 11, that is 45. So what would be the answer? 45 into this. So this is the correct answer. Okay. So now, let's see the next question. That is, which of the following statements is true about capillary events? Let's see. Firstly, what are these? According to Henry's law, pressure is directly proportional to solubility. See, when scuba divers will come towards the surface, when they will come towards, like when we go see to the mountains, if we go, pressure decreases. When we go up in the layers, the pressure will decrease. So it is like divers, when they come towards the surface, air pressure gradually decreases. Okay, so that is why this reduced pressure will release dissolved gases present in blood, and this will lead to formation of nitrogen bubbles in the blood. Okay, so if the bubbles will form when capillary, it will be blocked, and it will create a medical condition that is known as bends. Okay, and it is painful and dangerous. So let's see. Capillaries are blocked and it creates medical condition known as bends. True. They are painful and dangerous. True. These are the bubbles of helium. No, these are the bubbles of nitrogen. So this is the correct answer. Okay. So let's see the next question. That is, you have to match. Here, the we know that the orbital has five degenerate orbitals. So we have to match. See, the easiest to identify is always dz square. Right? It is always like this. So it is this. Now, if I have, say, for example, dxy, let me see if I have a diagram. Yeah, T. If I have dxy. So it will be like this. Okay, it would be between x and y axis. Only dx square y square is on the x and y axis. Remember this. So if I have dy z, it would be between y and z axis. See, it is between this in this plane. Dxz, it would be between x and z plane. Dxy, this is dz square. I told you dx square y square, and this is dz square. So upon matching, the correct answer would be this. Okay. Let's see the next question. Intermolecular forces are weaker than intramolecular forces. Which of the following interaction represent the weakest intermolecular force? We know that be it anything, the London forces are the weakest. These are the weakest. Okay. Af- Then comes dipole-dipole interaction, then hydrogen bonding, then ionic bonding. But the weakest are London dispersion forces because they are arising from the temporary induced dipoles. Okay, in the non-polar molecules. See, temporary induced dipoles in non-polar molecules. That is because of the movement of electrons in atoms and molecules. So, like if I had this neutral atom, so due to the movement, the charge will be separated and temporary dipoles will be formed. Let's see the next question. The amount of iron discharged during electrolysis is not directly proportional to. See, we know that W equals to ZIT, where Z is the equivalence, chemical equivalent, I is current, and T is time. So it is proportional to these. This is the correct answer. It is not proportional to resistance. There is no use of resistance here. Let's see the next question. A search says volume of a gas is inversely proportional to the number of moles of a gas. See, PV equals to nRT. So V is directly proportional to S, to the moles. So it is wrong. The ratio of by volume of gaseous reactants and products is in agreement with their mole ratio. We know. See, if say for example I have V1 volume of any reactant with N1 moles and V2 with N2. Okay, and these are directly proportional. If I divide these, then obviously their ratios will also be in agreement. So the reason is correct. So what is the correct answer? This. Let's see the next question. Solution bromoethane and chloroethane. See, for this, so let's see the options. Obeys Raoult's law over the entire range. This is correct because this forms an ideal solution. In an ideal solution, solute-solute interaction will be equal to solute and solvent interaction. The interactions between bromoethane and between chloroethane will be equal to interaction between bromoethane and chloroethane. That is AA or BB interaction are equal to AB type of interactions. Therefore, they are an example of ideal solutions. In ideal solution, del mixing V is equals to 0. So this would be our correct answer. And see, what is Raoult's law? It states that partial vapor pressure of each component of an ideal liquid, mixture of liquids, is equal to the vapor pressure of the pure component multiplied by its mole fraction. This obeys over the entire range of concentration. So let's see the next question. Okay. Which of the following statements is are correct, incorrect regarding photoelectric effect? The number of electrons ejected is proportional to the intensity of light. Yes, more the intensity of light, more will be the photons passing, and more will be the number of electrons ejected. There is some time lag between the striking this light beam on the metal surface and ejection. No, as soon as it strikes, the electrons are ejected. There's no time lag. The kinetic energy of an ejected electron depends upon the brightness. No. See, kinetic energy here would be equals to h nu. It depends on frequency, but not on the brightness. Kinetic energy, it is proportional to frequency. Yes. Our answer would be second and third. Okay. So this is the answer. The electrons are ejected from the metal surface as soon as the beam of light strikes the surface. And it is linearly proportional to frequency of incident radiation, but independent of brightness or intensity of the radiation. Let's see the next question, which is phosphorus pentachloride has a trigonal bipyramidal electron domain. See, this is the structure of PCl5. How many lone pairs of electrons on the central atoms of? Can you see any lone pair? No, so zero lone pair would be there. That's 5 valency and 5 chlorine are there to suffice it. The answer would be 0. Let's see the next question. On electrolyzing dilute solution between platinum electrodes, the gas evolved at anode. See, we need to write the equations at anode and cathode here. What would they be? At anode we have this, and at cathode we have this. At anode, what is happening? Oxidation. O2 is forming. So our answer would be okay. Let's see the next question. In a compound, C, H, and N atoms are present in 9 is to 1 is to 3.5 by weight. Molecular weight of the compound is 108. What is the molecular formula? For this, what we will do is, see, 9, 1, and 3.5 is the ratio given. We'll find the moles. Okay, by dividing by its atomic weight. We'll divide by atomic weight. And we'll have 3 by 4, 1 and 1 by 4. So which is the smallest, we'll multiply by that to get the whole number. Okay. So we'll multiply by 4. So what will come? 3, 4 and 1. So what would be the empirical formula? That is C3H4 and 1. Because 4H were there, 3C and 1H. And its mass is given to be 108. And what is molecular formula? N into empirical formula. So we'll just put this, equate this, and get N equals to 2. So molecular formula would be N into what would be the empirical formula. That is the correct answer. Let's see the next question. What does the following figure represent? See, what is the diagram for ideal solution? Would be this. If it is negative deviation, then we have this. If it is positive deviation, we have this. So it is non-ideal with positive deviation. So it is 1 and 4. 1 and 2. A non-ideal solution in which the interaction between solute and solvent or solute-solvent molecules deviate. They are not equal. Positive deviation is when solute-solvent or solute-solute molecules are weaker than solvent-solvent molecules. So negative deviation will occur. Total pressure would be less. It's positive, so it would be more. negative deviation, it would be less. Okay, that is why this is the correct answer. Now again, we have to match. See, in this question, let's see firstly what all these signify. These quantum numbers. Principal quantum number, that is n. It represents name, size, and energy. Like this is 3 is n. Like 3f is no orbital, 3d. So name, size, and energy of the shell to which the electron will belong. Okay. What is azimuthal quantum number? It is L. For example, if I have 4f, so L would be 2. 0, 1, 2, 3. L would be 3. S, P, D, F. Okay. So it tells about spatial distribution and angular momentum. And what does magnetic quantum number tells? It tells us the orientation and distribution of the electron cloud, and spin quantum number tells us the direction of electrons around its axis. So let's see now. Principal quantum number, it will tell us about right, energy and size. Azimuthal quantum number will tell us about shape of the orbiter. Magnetic quantum number will tell us about orientation, and spin quantum number. Yes, so this is the correct answer. Let's see the next question, that is, which of the following statements about lattice energy is not true? Okay, we have to tell the incorrect statement. It is the energy required to break 1 mole of an ionic solid into its gaseous ions. It is always a positive value. No, this is the incorrect statement, so this would be a correct answer. Can be negative as well. A higher lattice energy indicates a stronger attraction between ions and into solid. Yes, because you need to provide even more energy if attraction is stronger. Then only it will be dissociated into its gaseous components. Okay. It depends upon the size and charge of ions involved. Yes, this is also true because to break a lattice of Mg plus 2, you will require more energy as compared to Nf plus 2. So correct answer would be true. Okay. Answer this the we have to tell the incorrect. So this would be. Let's see the next question. The E naught values of this reduction are given to us. Order of the reducing power. See, more is the reduction potential, more is the tendency to undergo reduction. That is the excess oxidizing agent. See now, this is the order of reducing E naught reduction potential. B is the maximum, then C, then A. Okay. So if this is the order of reduction potential, that is oxidizing power. So what will be the order of reducing power? The opposite of this. So that is the correct answer. Wait. Just just a second. If there's a mistake here. B, then C would come. Interchange these. Okay, BCA. It would be BCA. So it would be A, C, D, reducing power. Yeah. Because if B is 1.5, then comes 0.85, then comes A. So that is the correct answer. Let's see the next question. Which of the following options represent correct limiting reagents? What is a limiting reagent which is exhausted firstly, okay, in any reaction? So let's find. See, in this 26 is the mass that is given for carbon. So we'll find the moles, that is 2.16. And for oxygen, 20 by 32, that is 0.625. So it's clear that 1 is to 1 is the stoichiometry. So O2 is the limiting reagent. Why? Because 0.625 is lesser than 2.16. Okay, so it will be exhausted first. So O2 is in these options. Let's see for another second option. N2 and 3H2. For N2, 60 by 28 will give us 2.14 moles. And for H2, 80 by 2 will give us 40. Now see, according to the balanced chemical equation, 1 N2 that is 2.14 will require 3H2 that is 3 into 40. Um, Wait. That is 2.14 mole of N2 requires 6.42 mole of H2. Okay. So N2 will be the limiting reagent here. For the next, we have P4 and PO. So C for P4, this would be moles into 4 into 31. That would be divided and we'll get 0.86. For NO2, we'll get 6.25. So P4 will require 3 mole of O2. You see? So 0.86 requires 2.85 of O2. P4 would be the limiting reagent. So what is the answer? Our answer is 4. Yeah. Or if you don't want to solve, then just see in general, like this is very directly. Like if 26 is required in two atoms are there, that is, for example, say roughly 10, 10. So 10 would exhaust first, so O2. Similarly, here in H2 and N2, you'll have 60 N2 for 60, so N and 30, 30. So it would be more than 30 because 3 divided by 80 would be more than that. So let's see the next question. Vapor pressure of pure benzene is 119 torr and that of toluene is 37 torr at the same temperature. Okay. So we have PB naught and we have PT naught. Mole fraction of toluene in vapor phase, which is in equilibrium with a solution of benzene, and toluene having a mole fraction of 0.5. Zero point 0.5 is the mole fraction of toluene. So 0.5, 1 minus 0.5 will give 0.5. Will be for benzene as well. Let's see. The mole fraction of toluene in vapor phase is X, that is gamma T. And it is given in liquid phase, that is Xt. So see what will be the total vapor pressure of the solution of that is the addition of both the components. So this is given to be this. On putting the values, we'll find it to be this. Now for vapor phase, we'll have into of the total solution, vapor pressure of the total solution, okay, equals to T of toluene. That is equals to this, okay. So we'll substitute the values. YT, this we know, we'll divide it by this and we'll get the answer to be 0.237. Let's see the next question. The orientation of an atomic orbital is governed by. Now we all know this. This is governed by magnetic quantum. But we have already seen it. Okay, represent the orientation. 99. Let's see. The concept of polarity is important in understanding intermolecular forces. Which of the following molecules is expected to be most polar? See, this is non-polar. So if I'll have it will cancel out of it. BF3 is also non-polar. So this is the case and resultant would be this and this would be cancelled out. SO2, this is polar. Why? Because it does not have this kind of structure where it can be cancelled. Okay, nitrogen also it can be. It is diatomic thermonuclear. So it will have zero. Let's see the next question. Last question. The EMF of a galvanic cell of silver, in that it is these are the potentials given. We know that E naught will be equals to E cathode or E more minus E less. What is this? Then zero point 0.8 minus 0.34, that will give us to be 0.46. Okay. This is the chemical reactions taking place. I hope you have understood all the questions. So thank you and have a nice day.